In this section, we'll study a little bit different kind of classifier called the K nearest neighbors, KNN. KNN is a typical example of a lazy learner. It is called a lazy, not because of its apparent simplicity, but because it doesn't learn a discriminative function from the training data set. That means there is no training step. The analysis of the training data is delayed until a query is made to the system. Now let's see the algorithm. It's quite straightforward and quite easily summarized in this way. You have to choose the number k and a distance measure. Now for the new sample, find the k nearest neighbors from the training data set and assign the class label by majority vote. Look at this figure. Now there are three kinds of points: O shape and triangle shape and plus shape. Now this one is new data point, and assume we chose k is 5. So we found k 5 nearest points from the data set. In these selected points, there are 3 triangles and 1 O and 1 plus. So by using the majority vote, we can decide the given new point must be a triangle. In this way, we predict the new data point. So it is a lazy learner, and there is no specified the training step. Okay. It's quite simple. In fact, this one is the simplest algorithm among all machine learning algorithms. Okay, here we have a pros and cons for the algorithm. It is memory based, so the classifier immediately adapts as we collect new training data. And prediction cost, it's increasing as number of samples is increasing. In many classifiers, training takes time, and through training, we build a model. So eventually, it's a kind of the weight, and then the separate will be made. So that when you try to predict, the cost of prediction is very low. No matter how many of the data points are used, it doesn't matter. Usually prediction cost is very low, although the training cost is high. However, for this algorithm, now there's no prediction step, no training step, there's no training step, but the prediction cost is high depending on number of data points. Furthermore, we cannot discard training samples because no training step is involved, so that we have to keep the training data points. In fact, for other algorithms, once we build the model, then now the training data point can be ignored. It doesn't have to be near around the model. We can discard. However, for this algorithm, you have to take the data points together, and then you have to use it. So storage space can become a challenge if we are working with large data sets. And for the method, right choice of k is crucial in many cases to get really good balance between overfitting and underfitting. In scikit-learn, and I believe the default number of neighbor k is 5, and you can choose a larger or smaller number. In my experience, about 7 for well-known data sets, and 7 is quite well working. 5 is also working well. Now, you can choose some distance measure, different distance metrics, because it's along with the number k, and try to find the nearest the points, which means that you have to have a distance metric to measure and compare the distances. The default and simplest measure is Euclidean distance, the L2 norm distance. And alternatively, we can use some other distance, like as in this Minkowski distance. And once p is 2, then that is Euclidean distance, and p is 1, then is L1 norm distance. You can use some other distance metric, but the default is Euclidean distance, and most cases is working well. Okay, that's it. It's a simple section, short section. Thank you.